When we say conservative vector field, ito yung mga work natin na hindi natin nire-regard yung path na pinanggalingan niya. So, for example, nagkaroon kayo ng isang state function. So, let's say enthalpy. So, yung enthalpy nung, let's say, 200 degrees Celsius, umakyat siya hanggang 220 degrees Celsius. So, usually, ginagawa lang dyan, pinapag-subtract lang yung two values na yon regardless of what happened during this increase in temperature. Kasi it doesn't matter kasi they are called state functions. While in the path functions, kinoconsider natin yung movement niya. So, technically, state functions are path independent because hindi natin siya kinoconsider yung path kung saan siya nagdaan. So, ano ba yung ibig sabihin ko? Let's go back to this example. Halimbawa, meron tayong vector field. So, alam natin na yung first path or yung first movement ng ating, let's say, a work na yon or any variable. I'm talking about the values for x dito. Start from 0 and then 2 and then 2 to 0 and then 0 to 0. So what I mean here is that when we say conservative vector field, pwede mo sabihin na wala tong technicaling work na nangyari kasi it just went from 0 to 0. Therefore, walang certain displacement na nangyari. Walang net na movement from its initial point to the final point. So, yon ang tinatawag na conservative vector field. And to solve for any conservative vector field, kung tandaan nyo pa yung test for exactness sa DE na or diffcal natin na ginawa, so that's just the same. You take the partial derivative of y for any function in the I direction, and then that should be equal to the partial derivative of the function in the j direction with respect to x. So, ito yon, something like partial y of x. So, gawin natin siya dito, no? So, ito kasi yon. So, if you take the partial derivative, so ito yung ating pinaka-expression ng ating vector field or force field. So, f is of xy is equal to xi and then minus square root of yj. So, sabi doon, you take the partial derivative of y for any I direction. So, kung ano man yung f of xy mo dito in the I direction, that should be equal to the partial derivative of your x of this function in the j direction. So, let's do muna yung first term. So, what is the partial derivative of this expression in terms of y dun sa I lang? So, diba, that is just x. So, you take the partial derivative of x with respect to y, and is this equal to the partial derivative in terms of x nitong ating j lang? So, that's just yung square root of y. So, square root of, or negative square root of y kasi may minus yan. Okay, so is this equal? So, what is the partial derivative of x with respect to y? So, diba 0 yan? And this one is also 0. So, therefore, they are equal. That's why our function should be conservative in this case. Pero yun nga, dahil sobrang limited lang ng ating ano dito, yung nangyari kasi sobrang limited lang ng ating value dito. So, kasabi ko kanina, may net ito kasi isang movement lang yan. Pero, remember, conservative pa rin siya kasi 2 points lang yan. Pag pinag-subtract mo tong dalawang points, that's actually the work. So, kung nagtatlo na yan, bago gumanyan, so technically, that would not be conservative. Pero in this case, since dalawa lang sila, so pwede pa natin sabihin na conservative yan kasi you just have to subtract the two states and you would be getting the same work. Same na kahit i-trace mo yung path nito, since isa lang naman yung path, so that should also be non-conservative in that point. So, parang ito is, we couldn't really conclude na, we still have another parang path na we can consider para mas magkaroon tayo ng concrete example. But this is just a concept. And this is what was done in the example. So, technically, ganun lang naman yun. Since the partial derivatives are equal, the work is conservative, that is path independent. Pero syempre, dalawa lang kasi yung ating given dyan, or isang path lang yung ating binigay. So, if ever na hindi to isa lang yung path, so, mas maganda makikita natin yung ating equation in that case. Pero, yun na yung concept nun. And to determine the potential function, respective integration will be performed, and we know that this is only applicable for conservative functions. So if ever na-test natin na the function is conservative or the force field or any variable na vector is conservative, you can do partial integration with each one of them, and then let's say you integrate it with respect to x and then yung isa is with respect to y. So in this case, di ba kanina, that's just x and then meron tayong negative square root of y. So you integrate this with respect to dx and then you integrate this y with respect to y. So kung ano may nasa nasa I direction, it should be integrated with dx, and then kung ano man nasa j natin, that should be integrated with our dy direction. So from this, ano ba yung integral? Sabi natin, the integral of x dx plus the integral of your n dy. So, hindi pala x but m. So, yung m natin ngayon, bibigyan natin ng values. So, yan. So, this is your function. So, ano ba yung ating m? M is equal to x, n is equal to negative square root of y. So, from this, the integral would be ito, x squared over 2 minus 2/3 y raised to 3 halves plus c. Okay? And yun na yung ating potential function na tinatawag. So, the potential function is equal to f and then x, y. So, ito yung ating potential function. And going back to the lecture, ito, for example, this number 3 can be solved using the vector analysis or vector functions. Pero since we use the line integral here, bakit kaya ganon? So, ginamit natin yon kasi hindi tayo binigyan ng vector function ng f natin or ng force field. So, we're given with the potential function, ito yon, x plus y squared minus z squared of x, the same way na ito yon. That's why if you take the gradient of this expression, you would be getting the force or the vector function that we can use. So that's why in this case, sabi dito, once you if you want to check whether the potential function is correct, you take the gradient of the scalar function obtained. So how do we solve for the gradient? So I just have to incorporate yung ating nabla sign. So yan yon, inverted triangle, and then you just have to write yung ating potential function. And then ano ba yung magiging sagot natin? So, in the vector field for x, so you just have to take the partial derivative of the whole expression, and then you just incorporate kung saan siya. So, first is the I direction. So, with respect to x, so ano yung magiging sagot dito? Diba? That's just x. So, yon. And then for y, so diba? That's 2/3 y raised to 3 halves times 3 halves. So, that's just y raised to 1 half. So, that's negative square root of y. And then this is your vector function, and as you can see, this vector function is the same as this one, that is xi minus square root of y j. So ito, this is how you write divergence, pero pwede mo rin siyang isulat in terms of f xy that is equal to x. Kung ano yung nasa una, that's I, and then minus square root of y j. Okay, kasi itong sign na to, these are indicators ng direction natin for vectors. Okay, so yun. So we've proven na correct siya in that case. If you do have this f of dr, and then if you take the gradient of the potential function, so you would be getting this result. If you substitute the upper limit of the interval minus the lower limit of that certain function, you should be getting the same result. So remember, yung ating potential function is this one. So let's start substituting the values. So therefore, if f dr would be our work, then it should be through that for f of xy in terms of b. So, ano ba yung b natin? Diba? That's 0 to 4. So, ito yung ating interval. Remember? So, from this, ano ba yung ating b? So, b is equal to 4. Therefore, that's 4 squared over 2 minus 2/3. And then, ano ba yung ating y? So, sabi natin, diba, the expression is actually equal to, when x is equal to 4, y is equal to 8. So, therefore, 8, and then we raise this to 3 halves, and then, you can add plus c, but since makakancel lang yan pag subtraction, so pwedeng din yun nailagay. And then we subtract this. So, kung 0 to, automatically maging 0 na. But this one, since it is 0 raised to 3 halves, so 0 na rin yan. Okay? And then therefore, we're left out with 16 over 2 minus 2/3 times 8 raised to 3 halves. And evaluating this gives you the same result for the work. That's negative 7.0849 work units. Okay? So, yun yung ating magiging sagot or our proof na if you have, let's say, a conservative vector field and then you want to take the potential function by using the gradient of by taking the gradient of this potential function, then it can be proven that for the potential function substituted with the upper and lower limits, the difference would just give you the same work that you were able to obtain using the equation of the vector field. So, from that, I think, nag-gets na siguro yung concept nun. So, hopefully, mag-gets siya. Nakakalito lang ng konti, no? Pero yung concept nito is just this. When you're given with the line integral, you can solve it either using the vector or the scalar form. Pag pag scalar, we use this kind of equation wherein we use the arc length. Okay? But when you're given with a vector function, and usually it is given by a vector field, so ito yon, you can use the vector solution FTDS, especially when dealing with work. Pero even if the function is given in a vector function, but you still want to determine the space of that region, you can still use yung ating arc length, but make sure na you turn all of this in terms of scalar function by taking the values of your r of t in terms of x, y, z in terms of t, and then yung ating derivatives for each values of x, y, and z, which will be coming from the coefficients of the directions here, that is I, j, k. And then you square that and then you multiply. So yun lang yung concept ng ating line integrals when you are given with vector but you want to solve it using the scalar quantities. You can also use yung ating vector solution by taking the gradient of this certain scalar function and then proceed with this kind of solution. So, pwede rin yan. And then we can also use a shortcut method whenever the vector field is conservative. Pero pag hindi, syempre hindi na to pwede, no? Okay, and then we can now proceed with the closed contour or the closed curve integral and using Green's theorem. So, I think that this is parang last topic na ba to or almost last na to. Basta, patapos na tayo, no? So when we talk about the contour integral, so this is often used to evaluate a contour or path in a given complex plane. So parang kamukha siya ng ating, di ba meron tayong mga dinrawing kanina mga ganito? So ito yan, parang ganyan din siya. Parang close contours lang din siya. Pero ano ba yung kinocompute dito sa ating close contour? So you can see, evaluate the path traced below using the theorem of line integral. So ang gagawin natin dito, if we want to evaluate the line integral in differential form of the closed curve, so we can always check if this is muna conservative. So the partial derivative of this expression with respect to y in terms of x lang, so that's y squared, that is equal to 2y. And then the partial derivative with respect to x for 2xy would of course give us the value of 2y. So therefore we can say that this particular curve y is equal to square root of 1 minus x squared is a conservative vector field or a conservative region. So with that being said, we can now proceed with the next step, which is actually finding the potential function. So yung potential function na to, since equal naman sila, so that would give you xy squared for each of one of them. Kasi kung bawa, y squared dx, you try to integrate this. This is xy squared as well as this one, xy squared din yan. So xy squared ang ating potential function. So this is our potential function in terms of the scalar quantity, and then to determine our work, so you can have the integral of f t ds, that is equal to your ano ba yung ating value when x is equal to -1. So that's, diba, this is from a to b, so if you'll be using yung ating expression dito, so we have this value, so that's 1 for x, and then ano ba yung ating y, so yung y natin is actually 0. So, 0 squared, and then we subtract yung ating values sa ating b. So, yung yung ating a, so ito yung ating b, ito yung ating a. So, yung a natin is -1, so that's -1, and then ano ba yung ating y, so that's 0 squared. So, therefore, our work in this case is actually equal to 0. So, from this, we can say na 0 yung ating magiging sagot, and we can check it using parametrization of the circle. So, pwede nyo siyang i-parameterize, and then using yung ating FDR, so hinanap natin yung ating f of t in terms of I and j. So, ito yon. Paano ba natin nahanapin yung r of t natin in terms of I and j? So, di ba sabi natin lagi ang ating r of t, pag parameterization naman, so we'll be using vector field, pero we have to incorporate yung ating I and j. Pero given tayo dito ng scalar quantity, so we have to transform this in terms of the vector field, so that becomes f, of course, f of t, so that is equal to ano ba tong y squared natin. So, di ba, if we have a value of 1 here for our r, so therefore, we can say na yung ating x is equal to cosine t, and then yung ating y would be sine t. So therefore, in this case, we have sine squared t, and then we have, ano ba yung ating dx? So that is the direction in terms of I. So yun na yun, and then plus, we have 2 sine t cosine t sa ating y. So that's j. So pwedeng ganito na yung ating function natin sa before we do parameterization. Kaya ito yung expression natin dito sa case na to, no? F of t is equal to sine squared t I, and then plus 2 sine t cosine t, and then j hat. But of course, yung ating r prime of t is obtained based on the concept ng ating r of t is equal to xi plus yj. So yung ating x is cosine, and then yung ating y is sine. So just add them, and then the derivative would be sine ti, and then minus cosine tj. So yun lang yun, and then just multiply and then integrate. So you should be getting also 0. So in short, kapag meron tayong piecewise function, conservative and continuous, so wala nang kinalaman yung path na dinaanan niya dito kasi di ba nagbabago yan ng mga values, but the point is 0 siya dito and then 0 siya dito. So yun, and then that's why the answer is 0 dito.